Hi, welcome to the Home Cinema Guide channel. This is part 2 of my DIY calibration process. I'm Jeff Meyer, retired AV calibrator and engineer. In this section, we'll be discussing how to select the basic settings in your display to prepare for color calibration of your product. At various points in this tutorial, you'll want to pause it so that you can do the actions requested at that point. You'll want to have something available where you can record the settings as you go along, so in case you want to go backwards, you'll be able to do that easily to what you had prior if you thought it was better than somewhere along the process. You will also eventually need the settings from this phase to be able to put them into other inputs and pass them on to the HDR and Dolby Vision settings when applicable. At this point, you need to go into your YouTube settings within this video and adjust the HD quality to 1080p. So you should cursor to where you can change the settings as shown and go in and change your set to being 1080p. You'll also want to be playing this video both on your display and on your phone so that you can check some of the things with your phone that you'll be seeing on your display. I would turn the volume down on your phone so it doesn't interfere with the sound from your picture while you're playing this. Or if you've bypassed your sound system, play the sound on your phone so that you can follow along with what I'm instructing. At this point, you'll want to turn off True Tone and night mode within your iPhone or iPad as shown so that it doesn't interfere with the color performance of the iPhone or iPad, which you'll be using to make some of your calibration decisions on your display. You'll also want to dim your room lights either way down or off so that you can easily see what's happening in the near black of your display. If you're calibrating a projector, you certainly want to get the room as dark as possible so that you have minimal interference with the image performance on your display. At this point, you'll want to match the light output of your phone to the display. So you should hold your phone up in front of you so you can see the display like this. So you can see your display and the phone at the same time. You'll then adjust the level within the phone to match your display as shown on the screen. The key thing to look at is the bright box at the bottom of the standard color bars here, and try to match the light output of those standard color bars to the display. You'll want to do this so that you don't get fooled by light output differences between the phone or your iPad and the display that you're trying to match it to. We're now going to move on to setting the picture mode in your display. Every display has a memory location where the settings are stored, and typically there's multiples of these available. It's pretty common in displays today, especially the flat panels, to have modes labeled something like Vivid, Sports, Movie, Cinema, Custom, User, or Memory. In general, this has created a lot of confusion that people think, oh, I need a separate setting for movies and sports and all these different things. That couldn't be further from the truth. All video sources should be following a specific standard, and there isn't a separate standard for sports versus cinema and other video types. There are different standards for HD versus HDR versus HDR Dolby Vision, things like that. Those are different standards, but sports and movies are not a different standard unto themselves. So an accurate image is really going to conform to one of those standards like HD, HDR, Dolby Vision, and not something specific to sports or cinema itself, actually. Where you may want separate memories are for different lighting situations within a room. So it is pretty common to have a lighting setup for a dark room and a bright room, especially with a flat panel. And you may also want a separate setting if you're zooming the image around on a projector to have something brighter when you expand the image, much larger on the screen, things like that. Those are basically light output reasons why you might want to have a different setting, or possibly for motion reasons. But when it comes to color, that's a specific standard, and you really don't want a separate setting for that. We'll now examine suggested modes that I have for various products. The first of which is a JVC projector. In the JVC projector, I would use user 1 and then rename it to SDR for stand dynamic range. For an LG OLED, I would choose ISF Expert Bright or ISF Expert Dark to start with. Modes labeled things like ISF, Movie, Cinema, User, Custom are common modes that turn out to be pretty good when it comes to being close to reference. When we choose a setting, we're going to be looking at the reference color bars and then also the color image of James Bond standing in front of a plane on Casino Royale. We'll start out here with the color bars, and you'll want to pick a mode in your display where the color bars on the phone most closely match the color bars in the display, and pay particular attention to the color of red. You definitely do not want a red that's orangey looking or very unsaturated. If nothing is super close, go ahead and choose one where the red is maybe slightly more saturated or more colorful than what it is on the phone. We're now looking at the image of James Bond standing in front of the plane. And again, review those modes where you thought the color looked best and see how that looks on the phone for this image versus the screen. If it's way off, you may want to go back to some other modes that you thought were close. At this point, we'll want to go back and recheck the light level on the phone to the display. Here are the color bars again, and pay particular attention to the white box at the bottom and make sure that your phone is matching your display as close as possible, and adjust the light level in the phone to get reasonably close to the light level on the display. Motion is the next thing that we'll address in the settings. And for this, we'll be looking at a bouncing ball pattern on your phone and comparing it to the display. Now, the brighter your display is, the more issues with motion you're likely to see or have. And you may have a very difficult time getting the motion to be exactly like you want it. In general, you may want a little bit of jumpiness to the motion relative to what you think you might want. There's this thing called soapbox effect where it's super smooth, but that can look very odd and really is not realistic for what 60 hertz or 24 hertz video really looks like. To start with, I would turn off all of the motion settings that you can find in your display and then start adding them in to see if things get better or worse by referencing the phone's image to what your display is doing. In general, projectors tend to have better motion processing in them than the current flat panel displays on the market. If you own a JVC projector, the settings can be found under Picture Adjust, Motion Control, and I would set Low Latency to On, Clear Motion Drive to Off, and Motion Enhance to Off. If you own an LG OLED, I would set the settings under Picture, Picture Mode Settings, and Picture Options. And under there, I would set Real Motion Off and True Motion to User, and De-Judder 1 and De-Blur 1. You may find you prefer other settings. There are reasons to have personal preference in this area, but I find that these settings are the closest to what a reference image in a cinema would look like. It's time again to match light level on the phone to that on the display. And we'll look at this pattern again here with the standard color bars and adjust the light level on the phone to come as close as possible to the display. Selecting motion settings can alter the light output of a product. Now we'll want to move on to matching the HDMI level of the input on your display to that from the source. In part 1, we set the output level from the source, and now in part 2, we're going to look at the settings in the display and make sure that they're reasonable for your setup. In a projector, you'll find a setting called super white. With the super white setting, your display can display information above the standard white point of 235. If this is a flat panel, that's really no problem because in displays today, you pretty much have light output to spare. But in a projector, you really don't want to choose this setting because you're going to lose 20% of the light output of your machine. And it's very rare to have excess light output with a given projector and screen. If you own a JVC projector, you'll want to go in and look at the settings under Input, Signal, and Input Levels and set it to 16 to 235 video. And if you have an LG OLED, you'll go into Picture, Picture Options, Black Level, and Low. We're going to look at the standard color bars again here. And in the lower right-hand corner, there's a dark gray bar on a black background. If you don't see the dark gray bar or the black background is glowing too brightly, you want to experiment with different level settings on the HDMI level choices within your product and get something where the bar is visible and the background is not glowing very brightly. Many projectors on the market have a setting in it which you can set for various screen types. I would disable this feature in every projector on the market. I've found that not many of these are very helpful at all, and they can be pretty problematic. So you're just better off turning it off because we're going to go through adjustments that would correct for color errors found in your typical screen on the market. If you own a JVC projector, you'll want to go into the installation part of the menu under Screen Adjust and turn it off. Now we're going to try and pixel map the display to the source. This is critical for obtaining the maximum sharpness from a product and is a major problem found in many flat panel displays on the market. The technical name for this is Overscan within a flat panel or projector, and what is happening here is that historically in standard definition, we had images that had closed captioning encoded in the top few lines, and CRT displays back in the day used to have an amount of overscan in them so that you didn't really see the whole image that was sent to you, and you really didn't want to because closed captioning was encoded in there in something that looked a little bit like Morse code. In a JVC projector, you'll find this under Installation Aspect, and the setting should be native. In an LG display, the setting is Picture, Aspect Ratio Settings, and then under Aspect Ratio, and you'll want to turn Just Scan on. For some reason, Overscan is still included in modern displays, and as such, we're losing resolution by not pixel mapping the display. You need to restore this to what it should be by looking at this test pattern that shows 7 segments on the top and the bottom. Now, as this zooms out, all 7 segments should always be visible. When we get to the pattern fully zoomed out, if all 7 segments are not visible, you need to find the settings in your display that allow you to pixel map it so that doesn't happen. They're usually going to be labeled something like Aspect, Pixel to Pixel, Just Scan, something like that. You may need to look at the manual to find them. For example, in Sony's, they really hide this very well within the settings of the product. Now we're going to look at the multi-burst pattern as another way to check as to whether we're pixel mapping properly. When we pixel map properly, the rightmost segments should be very fine lines, and as you move left, you should get wider and wider lines. The first set of line pairs is 1 pixel, then you move to 2, then 3, then 4, and so on. If this isn't happening, you may still have problems with overscan. If you have a projector, you may have a problem with keystone being on, and you should go in and turn any keystone correction off in your projector until you have fine lines on the right progressing to the left with fatter and fatter lines. If you're calibrating a projector, you'll find that you may have a dynamic iris function within that product. These are used to enhance the blacks, but unfortunately they can distort color and they can also minimize the impact of a scene by dimming the whole thing. I personally prefer these irises to generally be off, depending on the product and how poor the blacks are. But for calibration purposes, I would disable this function so you can see the near black detail and how this is interfering with it later when you enable that feature back again. If you own a JVC projector, you should go into Picture Adjust, and then Picture Mode, and then Aperture, and set it to Manual and 0. If you're calibrating a flat panel LED display, you'll want to minimize the impact of the dynamic LED function within it. I would go into your settings and either disable it entirely or turn it to low. If you find that the black levels are just horrific with it off, you might want to just go ahead and set it to low, but I definitely would avoid a middle or high level of this dynamic compensation, because you may find later after you've calibrated it that you really don't like its impact on the near black detail performance of the display. At this point, you'll want to adjust the overall light output level on your product to a fairly high level. When we start calibrating the color of white and the near black in the display, it's really important that you can see what's happening. And so you'll want to have the light output of the display set such that it's pretty bright. I wouldn't set it so bright that it's obnoxious for you to work on, but on the other hand, you don't want to struggle to see what's happening near black if possible. So if you have a JVC projector, I would probably try to run it in the low lamp load if possible. But if you have a large screen or an acoustically transparent screen, something around 120 inches or greater, and diagonal, you may want to consider running it in high lamp for calibration purposes, just so you can see what's happening near black and not miss something in the image. If you have an LG OLED display, I would go into the picture mode settings and then adjust the OLED light level to something between 100 and 50. Even in a very dark room, I probably wouldn't run it lower than 50, but somewhere in that range that's comfortable but yet bright is a really good way to calibrate a display. It's time again to match the light level on the phone to that on the display. And we'll look at this pattern again here with the standard color bars and adjust the light level on the phone to come as close as possible to the display. At this point, we'll want to disable all the video enhancements within your product. Unfortunately, in consumer flat panels, manufacturers like to throw in all sorts of features that really have nothing to do with great image performance, and they're there to add enhancement to the image, but it really detracts from what the director intended in the first place. So you want to go in and turn off things like dynamic contrast, super resolution, edge enhancement, noise reduction, things like that. You can always go back and turn these on later if you find that, oh, I really like that feature. But for the purpose of calibration, I would disable them at this point completely. If you own a JVC projector, I would go into Picture Adjust, MPC levels, set the graphic mode to standard, enhance to 1, smoothing to 0, and noise reduction to 0. If you own an LG OLED display, I would go into the picture settings under Picture Mode and Picture Options and turn noise reduction off, MPEG noise reduction off, smooth gradation off, motion eye care off. I would go into the picture setting and turn AI picture off and eye comfort mode off. I would go into the picture mode settings under advanced controls, expert controls, and turn dynamic contrast off, super resolution off, and peak brightness off. The next video section will be broken into two parts, one for projectors and one for flat panels. Projectors require quite a bit of special adjustment for geometry and focusing that really don't ever happen on a flat panel. And so I'm going to split these videos apart, and then in part 4, which follows that, we'll go back to doing projectors and flat panels together. So to continue, you should look for part 3A for projectors and part 3B for flat panels. Thanks for watching. Hopefully you're enjoying this. Bye.